Hello all, welcome to another Clojure Diary video. So today, like what we are going to see is like, yeah, we are going to start a new journey. Like till now, like I have done this Fibonacci series and all those stuff, and we were able to generate like Fibonacci at least up to like 500. Sorry, the first 500 Fibonacci we were able to generate, and thanks to big int enclosure and all those things. So I was going through this book, Classic Computer Science Problems in Python. So the first one was Fibonacci. So I think we just solved it. And next one was compression of files. Okay, so what compression I'm going to do here is, I don't know, like I haven't read this compression of files in this book, but I think I'm planning to read it. But in Clojure, I just want to do text compression and see how it works. Okay, so I think the subsequent videos in this channel will lay a groundwork for that. Okay, so yeah, let's see how to do some text compression and all those things. So for that I've downloaded this text, like it's called as Life on the Mississippi. Like it's by Mark Twain, and so yeah, so this is what we are going to compress and all those things. So to compress something, first we need to do some analysis, and then after doing some analysis, we need to find a generalized algorithm and all those stuff. So that like, well, okay, like no matter whatever text file you just give, it just compresses, and then yeah, you'll be able to uncompress and something like that, right? So this thing, like okay, like I am not sure like how big it is. So, but I think it is okay, like okay, file size in Linux. Okay, so okay, finding file size. Okay, so let us find the file size of this one. Okay, so this is the stuff, ls hyphen l, and then yeah. So let's try this. Let me just launch a terminal right in my VS Code, and it is 2445. Yeah. So I think it is so much kilobytes. So I think it's around about like 843 kilobytes and something like that. And so yeah, we need to somehow compress it. Okay. So I don't need this terminal anymore. So let me just. Okay. So I've already done a program like this, but yeah, I'll be recreating it. So I done it so that like today's demo will go smoothly, right? So let me put a file name called text analysis. Okay, and in this file, I'll be arriving with to almost a solution like this one. But yeah, I just want to show it live so that like people who are learning Clojure will benefit. So that's the thing. And let me launch my app, right? Ripple. Okay. I thought the Ripple was already connected. Okay, so hopefully things work. Okay, looks like the Ripple works. Okay, so that's the thing. So first let's have a variable name file, right? And let's keep it this name, like 245 dot txt, right? And yeah, so we just have this, right? And now we need to read the file. Okay, so for that, like I'm just going to use the arrow thing. So I don't know what it's called technically. Actually, somebody in Reddit did put that name when I uh, did a video about this arrow thing. But the thing is, like, I just forgot like what that name is. Okay, so we just have this file. Okay, so here, and next we are going to pass it to a thing called slurp. Okay, so slurp, we are just going to pass it, and what happens is this just reads the file. Okay, so the entire file is, oh my god, it just puts the entire output to here. Okay, fine, right. Okay, so that's too much, but okay, yeah. So that's the thing. Now what we need to do is, like, we need to split it into words. Okay, so let us have something like, okay, like uh, a function called words, and this will receive some text, and then this needs to be split. Okay, to split that, we are going to use a thing called Clojure string. Yeah, so over here it is. And then what we are just going to do is, like, we are going to split text. Okay, and then to this we are going to pass a regular expression. But if you don't know regular expression, do read about it. So what I'm just going to do is, like, I'm going to split it with spaces. So this slashes means space, and this means one or more. So if you have one or more space, do split it. So that's what this says. And okay, so that's the thing. So now let's uh, load this. So words is there, and then what we are just going to do is, like, okay, words split into words, right? So you just get it. Okay, you just get it as a vector. Okay, so that's how it is. So now we are going to put this words over here. So we are just going to get it, right? So yeah, this is how it is, and you just get all these words over here. Right? So lot of words. So but then you just see, like, okay, like okay, if you look at the text over here, right? So let me take this text over here, right? uh, okay, so a word is not something like, okay, like, look, you have something like, okay, like, this will be treated as one word. Okay, 152 comma hyphen hyphen and it. Okay, so this will be treated as one word because we are just splitting it by spaces. Okay, so that's not the right way to go, because hyphen hyphen more over here, that's not one word. More is word. So what we can do is, like, we can take this non-letter characters, okay, and we can replace it with space, so it will become something like this one. And now if we just split it with words, it will, what to say, like, it'll be good. That's what I just feel, right? So let me just do that. Okay, so I think there is a thing called replace. Okay, so okay, for that, let me write a function. Okay, so let me just put it like remove punctuation. Okay, so punctuations. Okay, yeah, text. Okay, so we have okay, like, closure closure string, and I think we have a thing called replace. Okay, replace is there, and over here what we are just trying to do is slash ws. Okay, so if you don't know about regular expression, do read it. Maybe I will put some links about, like, regular expression books and something like that, so that, like, you people can know about it. It's a very, very powerful feature. So what this does is, this looks for non-word characters, like, okay, like any punctuation and all those things, one or more punctuations. and then it what to say, then it just replaces it with the space. Okay, so that's what I just think this is. Okay, so let me just try this out over here, right? uh, okay, so def text a, no punctuation. Okay, and okay, so we have got text over here. So all we just need to do is try this out and see. Okay, looks like the punctuations are removed, right? So that's how it is. Okay, and yeah, so we have just got this. Okay, so what I just do is like I just put like remove punctuation, and then this pass two words. Okay, before that, okay, like let's uh okay, yeah, let me just put like this. Okay, okay, remove punctuations and then something like this. So I don't know the count of this. Okay, like okay, but yeah. Anyway, okay, yeah. I need to load this. Yeah, now I'll just put this. Okay, so this is totally punctuations removed and all those things. Okay, so like right. Okay, so what I can just do is like okay, this is good enough. I'll just form this into a function called birds in a file or something like that. Right. So okay, so let me just put it into a function, right? And this goes over here, and words in file. Okay, and we just take file as input, and of course that file becomes this one, and okay, just what to say, it slurps it, removes function punctuations, and then what to say, returns the words in it. So no matter whatever file you just give over here, that is like in the future, like okay, whatever file you just use, it's just going to work. Okay, hopefully, yeah. So and it should be a text file. So let me just load it into Ripple, and let me try it out. Words in file, and then let me just give a file over here, right? So yeah, so we just put it into a function, and yeah, that's it. So let us do some text analysis with it. Okay, so let me have okay, like a variable called word collection, and then to it let me just pass this one, words in file, and to this file, right? Now okay, oops, I don't know, if I do some key press, this is just going all up. I don't know what it is, but so you just have this word collection, and let's just see what it is. Word collection. So it is the same thing. Okay, so let us now count it. Okay, so it is like okay, like 1 lakh. Sorry, it is like 1,000, and then 52,000. Okay, it is like 152,000. If you're US people, or like if you're Indian or something like that, or something like Indian subcontinent, it's like 1,52,408. Okay, so many words we are just having, right? So yeah, that's the thing. And now let's see how many unique words we are just having, right? So okay, like how many unique words? Okay, so we'll just put count. Okay, so let me just put it as another variable. Okay, unique words, and then word collection, and I'll just pass it to a set so that like so now if I just put count of unique words, it is like okay, 14,228. So let us try to divide this, right? So I just want it to be decimal, I think double. Okay, yeah, I think there is a thing called double. Divide it. So roughly one word is appearing 10 times or 11 times on an average. Okay, so that's the thing. Now if I want frequencies of word, okay, so what I can just do is there is an excellent function called frequencies. I don't know who wrote it. Frequencies. Okay, and then word collection, right? So okay, so this is the frequency. So it says like okay, military appears 7 times. Okay, so that's the thing. Jurisdiction appears 1 time, and so I think like it's better to compress military because military is like okay, like 1, 2, 3, 4, 5, 6, 7, 8 characters into seven. So 7 8s are 56, and jurisdiction is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it is 12 characters. So 12 into 1. So it's only okay if you just look at the compression rate. Okay, like it just appears only once. Okay, and it's just 12 characters. So even if you somehow substitute like the kind of weight, okay, if you compress something, I just want to know like okay, if you compress a word, I just want to know like how much times it occurs so that like the compression is more effective. Okay, so like this jurisdiction only appears once. Okay, so if you just compress it, okay, like it won't be much effective, but military will be effective because even though if it's smaller than jurisdiction, it appears 7 times. Okay, so there might be words that appears lot and all those stuff, and so yeah, we need to find those kind of words and compress it like so how compression will work. Okay, so let's say like I just have huge stuff like let's say this is a text. Okay, so a and then b and c and d and once again a. Okay, how many a's over here? So okay, let me just copy this, right? Okay, so a and yeah, once again a. So if you just look at this, okay, so I just have this a's over here. So think like I can just build a map or something like that where I can just put something like okay, like a is okay. Uh, okay, so and then I can just replace all this text with just one a. Okay, so now rather than okay, like this all this A's appeared like okay 1, 2, 3, 4, 5, 6. Okay, they appeared 3 times. Okay, but now I'm just replacing with 3 characters. So this 18 characters is being replaced with just 3 characters. Okay, but if I just compress this B, okay, so like, okay, it is like 1 2 3 4 5 characters, this one. Even if I just replace this with B, okay, so like this, and if I just do this, okay, and the compression gain will be only very less. Okay, so that's the thing. So what I just want to do is like compute some kind of compression gain or something like that, and that's what I just want to do. Okay, so I hope you get it. But yeah, let me just go through what to say, what I'm just doing, and let's see how it just folds up. So yeah, I'll just refer this thing like this text analysis and all those stuff. Okay. Okay, then yeah, I just need to what to say. Uh, do this one like word frequencies in a file. Okay, so and I'll just write that function, right? So word frequencies in file and file. Okay, so what I just want is like, okay, this uh take okay, like I just have this frequencies, and then I just have like words in a file, right? And then I just have file over here. So that's it. So hopefully this works. I think we need to put another. So hopefully this works. So let me just try to use it. Okay, so we are just getting it, but I just want to write it better. Okay, so let me just put it something like this. Okay, so you just have this arrow function, right? And we have file over here, and we have like words in a file, words in file, and then we pass this to frequencies. Okay, so that's it. Okay, so let me remove all this extra stuff, test it out. Okay, it looks like it still works. Okay, so word frequencies in a file we just have and all those stuff. So right from this file itself, we can get this word frequencies. Okay, so that's the thing. And okay, so now I just want to take this word frequencies, okay, and then look at the compression gain. Okay, so the compression gain is nothing but let me just write it. Okay, so to this we pass word frequencies. Okay, so I hope the spelling is right. So, so what I just want is okay. I want to take each and every element. Okay, so sure. Okay, so like Before that, let me just put this into a variable called word frequencies. Okay, so word frequencies, it's there. Okay, so now, okay, like for the time being, let me just map, and then so you just have this thing, right? So let me see what happens. Okay, so map this thing and then word frequencies, right? Okay, so load it. Okay, so let's test this out. Then we just have like, okay, let's take the first five word frequencies. Frequencies and see it's an error. I'm not sure what happened. Printing, returning. Mhm. Okay. I did pass. Okay, let me see what I've done over here. I've just passed the same stuff. Okay, so let me just do something like this one. Okay, like first and then, okay, load this compression gain once again in Ripple. Okay, and then, okay, so you just get it. Okay, so this is how it is. Okay, so now it just prints the words. Okay, so now what I just need to do is, okay, like let me just open a lead block. Okay, so lead, and then over here I just have I hope I'm doing it right. Word is nothing but, okay, like okay, like first of whatever argument you just pass in, and then let me just return word over here, right? So that's it. Okay, so let me just see whether I'm just getting the same output. Yes. Okay, so now I just want word length. Okay, so word length, and then let me just put like, okay, uh, count of word, right? Let me just test it out. So this is what I just like in Clojure. Look, I can just run it, and just do it. Okay, so okay, looks like the word length is working, and now I just want the frequency. Okay, actually, I don't know, like whether to call this frequency or number of occurrences. Okay, so let me just put like okay, like number of occurrences. Okay, right. So I'm not sure about the word. Okay, so like okay, let me just put it like word count. Okay, so word count. Okay, so, yeah. So this is nothing but the last of. So whatever happens is like okay, this just comes like okay, like extracted to. So we'll just get it like okay, like this extracted and two like this. We'll just get it as a vector. So I'm just the first one is the word. Okay, the first one is oops. Okay, so the first one is the word. The second one is or the last one is nothing but the count. Okay, so that's the thing. So now let's look at word count. Okay, so okay, hope it works. Okay, so I think this is the right word count. Let me just check it. Oops. Okay, 15141. Yes, right. Okay, so this is working. So, like, what I just want to do is, like, I just want to put something like, okay, okay. So let me just put a thing called gain over here, right? This is nothing but the multiple of word count, word length, and yeah, word count. Okay, so word count. Okay, and then let me just put a list of gain, and then okay, like word over here. So hopefully I'll just have something like this gain and word as list, and this map will return this list of list, and then yeah, I can just sort it, all sort of stuff and all those things. Okay, so hopefully it works, right? So oops, why it isn't working? Right, okay, compression gain. I don't know what happened. Right. Enter, option enter. I think something happened to the ripple, so it stopped working. Okay, so let me just. Okay, let me just rerun it. I think after the last Calva upload, I think there is some kind of problem, but I'm not sure. Is my Ripple even working, or is even Calva working? Oops, I think it just crashed. Okay. So if anybody is in Calva and they are just, oops, I don't have video editing tools and all those stuff, so I can't edit this out. Okay. Let me just quit my editor and just try it again, right? Okay. Hopefully it works. If Canva doesn't work, yeah, I'm just kind of out of luck. Okay, so I just need to do another video and all those stuff. I'm not sure. Right? So hopefully this one works. Okay, let me just test it. I don't know why I'm just doing all this stuff like this one and one. So yeah, I think I need to load everything. So let me load file. Let me load words. Let me load remove punctuation, words in file, word frequencies. Okay, and then compression gain. Okay, so that is there, and then now I just need to do this one, right? So let me just put it in a global variable, right? Word frequencies, then remove the stuff off. Okay, if you're deleting and if the bracket is not deleting, what you just do is like press option or alt, and then you can then delete it. Okay, so that's the thing. Okay, so uh I'm not sure what's happening. Okay. Okay, right. Did I put something wrong before? I'm not sure. And I'm too lazy to frequencies. Okay, yeah, I think we are just getting it. So let me just put this word frequencies. Oops, come on. Okay, so we're just getting it. So we need to pass it to this compression gain. Okay, so compression gain, and I don't think we need this user and all those stuff. Okay, so it just says like, okay, like if you compress Paul, okay, like the length of Paul and the number of occurrence of Paul is like 140. Okay, so that's the thing. So I think it occurs 36 times. Okay, so I think no, I don't know, like 140 by 4 is how much? I'm not sure, right? So 25, okay, it occurs 35 times. Okay, so that's the thing. And of this capital OF occurs 16 times and all those stuff. But yeah, if you just compress it, yeah, the compression weight is 32. So all I just need to do is like sort it and do all those stuff. So there is a function which I wrote like that. Okay, so what it does is, okay, like I just have this result. Okay, so compression gain. Okay, so let me just put it into a variable called gains. Okay, so that's the thing, right? So now I just need to sort it. So for that, there is a function called sort by. And look, the gain has nothing but like, okay, like, okay, the first one is the gain. Okay, and the second one is the word. You don't need to sort by word. You just need to sort by the gain. That is the first one, right? So there is a thing called first. Okay, and then I'll just put gains. Okay, so okay, so let me just put like, okay, like okay, like take 10 or something like that. Okay, so take 10 and then just have this. So look, you just have it. Okay, so if you compress xx, it's only 2. Okay, so and if you compress 51, it's still only 2. Okay, so let me just okay, so this is the sort is like it's from lowest to highest, and now I just need to reverse it. So there is a way to do that. So I think, okay, there is a thing called reverse. Okay, so that I'll just try. Okay, so let me just try it. Reverse. So if you compress the it has a compression gain of 25530, and is like 1716, and it just kind of rapidly drops off. So the thing is, like, we need to assign a character. Let's say, like, let's replace all the with just a character called a or something like that. Okay, so and let's replace all and with a character called b. Okay, and so on and so forth. So if we do that, so finally, like, at last what happens is, like, okay, we will get a file that's hopefully get a file that's far more smaller than what we just have. Okay, so that's the thing. But yeah, now let me just put this into a function like this reverse sort by and all those stuff, so that if I just pass a file, it will just return the compression gains. Okay, so for now there is already a thing like what I just wrote. Okay, so let me just copy paste it and just explain it. Okay, so what we are just doing is like, okay, like we are just getting a word frequencies in a file, right? Then we are just doing the compression gain, and then we are just passing it to sort by. Okay, and then we are just reversing it. Okay, so this is the function over here, file compression gain, right? And now I just need to pass file to it. Okay, so file compression gain, and let me just pass file to it. And then, okay, I don't want to list everything. I just want to take first 10 out of it, right? So that's it. So from this file, if you just give a file path or whatever it is, so I think you can even give the file URL, right, directly from Project Gutenberg. So it just returns the compression key. So this is what, okay, yeah, today video is about. And possibly soon I'll just return with another video where we just compress this file and compare its file size, see whether it's really what to say, going down or going up or something like that. And then, yeah, we need to write a program where we can uncompress it so that we can get the original file back. Okay, so yeah, that's it for today's videos. Yeah, I'll just put all the links and all those stuff in my blog, so that, like, you can just see it. And yeah, that's it for today. Have a nice day.